Hi, welcome back to the channel. In our last lesson, we saw how to perform binomial expansion using the binomial theorem. In this lesson, we're going to see how to perform binomial expansion using combination. Don't be scared, they are very much related. That said, let's get into class. In our last lesson, we saw that if you have a plus b raised to power n, we say is equals to the summation of, here is n, r is equals to 0. You have n factorial over n minus r factorial, a raised to power n minus r dot b raised to power r. In our last lesson, I showed you that n factorial over n minus r factorial into r factorial is the same thing as n combination r. That means I can equate this to mean the summation of n, r is equals to 0, n combination r dot a raised to power n minus r b raised to power r. Now let's expand this, because if this is the summation notation, we can remove the summation notation, then we can expand this to mean, because we can remove the, now let's expand this, we can remove the summation notation, then you should understand that this summation notation implies that r will consider the case when r is equals to 0, r is equals to 1, r is equals to 2, up till r will be equals to n. Now that tells us that my a now plus b raised to power n will be the same thing as c raised to power n 0, that's when r is equals to 0. Here is a now will be equals to n minus 0, which is n, b raised to power 0. Now we look at the second case when r is equals to 1 plus c again, that's combination n, here is 1. A now will be raised to power n minus 1 dot b now will be raised to power 1 plus, that will be the second case when r is equals to 2, that's c again, n combination 2, a raised to power n minus 2, b raised to power 2. Now you continue this in the series until you get to the point where c now will have combination n, a will be raised to power n minus n, that a raised to power 0, n minus n is equals to 0, b raised to power n. Now with this is our combination method. This is what we're going to use to solve our combination method, so that will give you a chance of picking between any that is convenient for you, whether the binomial theorem method or you want to use the combination method. We'll use this example to help us understand how to use the combination method, and at the end of this example I will also drop a take-home example for you, which I would appreciate if you can share your results with me in the comment section. That said, let's continue. Now we're going to expand. We're expanding 2 plus x over 2 all raised to power half. Now this is equals to, remember our combination method. The combination method is basically the summation of, this is n, r is equals to 0, n, I have n combination r dot a now raised to power n minus r dot b now raised to power r. Now let's analyze it. In this question, our n, obviously, in this question, this implies that our n is equals to 5. That means our r is going to range from 0, 1, 2, 3, 4, and 5. Then our a in this question is equals to 2, and our b will be equals to x over 2. Now, so that 2 plus x over 2 all raised to power 5 will be the same thing as c. Remember our n in this case is 5, combination 0, then I'll have 2 raised to power 5 minus r, that's 5 minus 0, into x over 2 into raised to power 0, plus c, that's 5 combination 1, and now I have 2 raised to power, now 5 minus 1, that's 4, then I'll have x plus x over 2 all raised to power 1, plus 4 combination 5, that's n is 5, 5 combination 2, this time into 2, raised to power 5, that's n minus r, 5 minus 2, that's 3 raised to power 3, into x over 2 all raised to power 2. Now plus 5 again, combination 3, 2 raised to power n minus 3, n minus 3 is 2, dot, let me use a dot here, x raised to power, x over 2 raised to power 3. Now plus c, that's 5 combination 4, that will be 2, now be raised to power 1, 5 minus 4 is 1, dot, the whole of x over 2 all raised to power 4, and plus, lastly now I've gotten to when r is equals to 5, so that this is 5 combination 5, 2 raised to power 0 into x over 2 all raised to power 5. Now we can expand this expression to mean this is equals to 5 combination 0, that will be 5 factorial over 5 minus 0 factorial. Now we can expand this, but let me rewrite the combination. If I have n combination r, remember it's the same thing as n factorial over n minus r into r factorial, so that my expression above, let's rewrite it here. Permit me, let me copy this. Here I can select it. Ouch. Okay, it was difficult to copy here. I might need to rewrite it, Oliver, so that my expansion, the first expansion was 5 combination 0. 5 combination 0 is something as 5 factorial over 5 factorial 0 factorial dot 2. My 2 was raised to power, let me see, power 5 minus 0, that's power 5. 2 raised to power 5 into x over 2 raised to power 0. Now plus, the next should be 5 combination 1, that's 5 factorial over 4 factorial 1 factorial, then my 2 now will be raised to power 4, then my x over 2 will be raised to power 1. 5 combination 2, that will be 5 factorial over 2, 5 minus 2, that's 3 factorial, 2 factorial, then my 2 will be raised to power n minus r, that's 5 minus 2, that's 3 into x over 2 all raised to power 2, plus the next will be 5 combination 3, which will be 5 factorial over 5 minus 3, that's 2 factorial, 3 factorial, that will be 2 now will be raised to power n minus r, n minus r, that's 5 minus 3, which is 2, and x over 2 will now be raised to power 3. The next will be 5 combination 4, that will be 5 factorial over 5 minus 4, 1 factorial, 4 factorial, then 2 will be raised to the power of n minus r, which is 1, and x over 2 will be raised to power 4, plus 5 combination 5, which is 5 factorial over 0 factorial, 5 factorial. 2 now will be raised to the power of n minus r of 5 minus 5 plus power 0, and x over 2 will now be raised to power 5. Now, so that this now, I can equate this to mean, if you look at this, I have 5 factorial over 5 factorial, that is 1. I have 0 here, that's 1. X over 2 raised to power 0 also, that's 1. Then I'm left with 2 raised to power 5. 2 raised to power 5 is 32. Plus, now let's come down here. This 5 factorial over 4 factorial. I'll use this little space for calculation. 5 factorial over 4 factorial, that is 5 times 4 factorial over 4 factorial. 4 factorial cancels 4 factorial. I'll be left with 5. Now 5 now. Now I have 2 here. I have 2 raised to power 4. 2 raised to power 4 is 16. 2 here is 1. 2 in 16 is 8. So I'm left with 5 times 8. That's plus 40x. Now the next is 5 factorial over 3 factorial. Okay, let me use this space below to do my calculation. Once again, I'm finding it difficult to delete the other one. Now, the next now I'm left with, the next is 5 factorial, that's this is the next, 5 factorial over 3 factorial and 2 factorial. 5 factorial again is 5 times 4 times 3 factorial over 3 factorial 2. 2 is 2 factorial same thing as 2, so this can cancel this. 2 here is 1, 2 in 4 is 2, so I'm left with 10. Now I can confidently replace this with 10. So 2 here, then I have x 2 raised to power 3, and I have 2 raised to power 2 here. That is 2 raised to power 2 here is 4. Technically, please follow me. And this 2 raised to power 3, so that leaves everything here to be 2. 2 times 10, that's plus 20. X raised to power 2 plus, I can confidently delete this. Now the next is 5 factorial over 2 factorial 3 factorial. Once again, that's 5 times 4 times 3 factorial over 2 factorial 3 factorial. 3 factorial cancels 3 factorial. 2 factorial is 2, that's 2 times 1. 2 here is 1. 2 in 4 is 2. That makes everything 10 once again. So what I have here also is 10. Then I have 2. I have 2 raised to power 3. This raised to power 3 will affect this 2. It's 2 raised to power 3. I have 2 raised to power 4. 2 raised to power 4 will cancel 2 out of the 2 raised to power 3. Then I'll be left with just 1, 2 here. 2 here is 1. 2 in 10 here will be 5. So I have 5. Then I have my x raised to power 3. Now let's look at the next one down. That's this one. Now I have 5 factorial, that's 5 times 4 factorial over 1 times 4 factorial. 4 factorial here is 1, 4 factorial here is 1. That's, I'm left with 5 factorial, 5 not factorial. So everything here is 5. Then I have 2 raised to power 4 and I have 2 raised to power 1. 2 here, we remove one of these, I'll be left with 2 raised to power 3. 2 raised to power 3 is the same thing as 8. Then I'll have plus 5 over 8 x raised to power 4. Now you have 5 factorial here, cancels 5 factorial. 0 factorial is 1, that's plus. Now 2 raised to power 0 is 1, so I'm left with x raised to power 5 all over 32. So my expression now becomes 32 plus 40x plus 20x squared plus 5x raised to power 3 plus 5 over 8 x plus 5 or x raised to power 5 over 32. With that, I hope you fully understand how to solve binomial expansion using combination. Now, I promise leaving you with a take-home example. Now, here's my take-home example. You can try your hands on this and let's know your results in the comment section. Thank you. I'll see you.